Hello again. In this lecture, we are discussing the measurement in chemistry. Measurement is the cause of the scientific and industrial development these days. Why? Because we could discover new tools by doing an accurate measurement and getting a precise and accurate tools that can help us to new and open new horizons to us and help us to dig deeper in the scientific fields. And as a result, we could invent new devices and open the new fields for the industry that helped the expanded the tradition and increased the ability of the people to invent new things. So measurement is a word that we are using regularly in our daily life. But if I asked you, what is measurement? Automatically, when I tell you measure something, then you are recognize that or understand that this matter that you will measure is unknown. Unknown in the mass, unknown in the tallness, in the height, in the weight, unknown in any physical property, then there is something is unknown and you are going to measure. This is the base of the measurement. But what is the idea of measuring or the measurement? The idea is to compare your unknown matter with another one is known, a reference one. This known one is the reference that will determine the quantity of the unknown matter that you're measuring. For example, if you have one piece of meat and you don't its mass, this is a piece of meat on the balance here, and you don't know its mass, then you're using this balance to measure the mass, and you're getting another mass or another quantities with known mass. We are calling them scales. So the scales are known quantities measuring the mass. This one here has mass equals 1 kilograms. 1 kilogram. Then you're comparing and balancing between the two sides of the balance. At the moment the two sides get in the same line, be in the same line, that means the balance is balanced and you will be able to know the quantity of meat or the mass of this meat. Because you know previously the mass of your scales, so when they are equaled, and you know that because the balance is in as the same line, then they are equals and they are equaled, and you know the mass of your known matter is existed inside the unknown matter. This is the idea of measurement. So measurement is a comparison between two quantities. One is unknown, that you're measuring, and the second is known, which we are calling the reference, and the scales, which we are talking about the balance here. The the only thing that you must notice that when you're comparing between the two quantities, they must be of the same physical kind. They must be both are masses, the both are um heights, the both are let's say hardness. Then you're comparing between quantities or matters or things of the same kind, properties of the same kinds. Okay? Why we are doing measurement? to know how many times the first, which is unknown, includes the second, which is known. So measurement is a comparison between two quantities. One is known and the other is unknown. Let's say the unknown is number one and the known is number two. They must be of the same kind to know how many times the first, which is unknown, includes the second, which is known. This is the measurement. There are three main things you must notice in measurement. When you're doing a measurement, you're getting a results, numbers at the end of your measuring process. Then these numbers are called the numerical values. So the numerical values are the numbers that shows you how many times your matter, which is unknown, includes from your reference. We are using things as a reference for the measurement process. We are calling this reference as the measuring units. The measuring units means the units of the thing you're measuring inside your unknown matter. And to know the number of these units, we are getting the numerical values. This is the idea. So the numerical values are the numbers which describe the measured quantities. The measured quantity. The suitable measuring unit is a certain physical quantity, or certain physical portion, okay, approved by laws. What I mean with approved by laws, that you know it's a quantity by laws, and we are agreed on its we are agree on its a quantity. So the units we are agree in accepting this for this unit for a specific physical quantity, and they proved that with physical laws, and they use these units as a standard to measure the actual magnitude, the actual portion, the actual physical quantity of the unknown. Okay? Okay. So the suitable measuring unit is the magnitude of a certain portion of a certain physical quantity. Magnitude means a portion, means amount an amount of certain physical quantity. So this is the meaning of magnitude. Magnitude means amount, means portion. Okay. So the suitable measuring unit is the magnitude of a certain physical quantity. How did know it's a quantity? By physical laws, approved by laws, and used as a standard to measure the actual magnitude of physical quantity, to measure the quantity of the unknown. Let's go further. During your measuring, there are errors that will face you, maybe because you made a mistake, or there's a problem in the tools you're using in the measurement, or maybe because of the condition that you're doing the measurement inside. I'll mention an example for you here. If you went to the jewelry shop and you want to sell or to buy a ring, then the person there who worked there will put the ring on a balance, sensitive balance. This balance is covered with a box of glass. Why this balance is covered? Because it's very sensitive. So if we didn't cover it, the air, the pressure of the market of the shop will influence on the measuring results. That's why the conditions is very important in determining your results of the measurement. So certain errors ratios will face you. Why we will face errors? Maybe due to an error in the used device, and we are calling these errors as instrumental errors. So we're calling the errors in the used device as instrumental errors, or maybe because of the conditions. And we're calling the errors caused by the conditions the errors in the methods, errors in the measuring methods. And in final, or in the end, there is an errors caused by the user. We are calling them operational errors. The errors caused by the user, by the person who's measuring, we're calling them operational errors. There are other more errors, but we'll not mention them because they are the most common errors that we may face us in our laboratories. The importance of measurement in chemistry, or in chemistry. Actually, these may be similar with the importance of measurement in other fields too. They can be accepted in other fields too, not just in chemistry. So the importance of measurement. Used, the measurement is used to know the kind and the concentration, the kind and the concentration of the substances we use. As you know, chemistry is interested in studying the composition of matter, so we must know the substances, and which means the composition, and the concentration of these substances. So the measurement is important because we use it in determining the type or the kind and the concentration of the used substances, of some substances. Number two, measurement is essential for protecting and controlling, in protection and control. Why? I'll discuss it further in the next few pages. Number three, measurement is important because it helps us evaluate the situations, propose solutions, and expect the future problems. Okay, expect the errors. So measurement is important in evaluating the situations, proposing solutions for problems, and also measurement is very important in predicting the future, the maybe the problems that may face us in the future. Okay, great. Let's go. Number one, measurement gives information about the type or the kind and the concentration of the substances, which are the elements forming the substances. Okay, okay. So let's give me an example here. In your student book, there is this example. Here is a table, and this table comparing between two bottles of water. One is titled with A, marked with letter A, and the other is titled with letter B, small light B, okay, B for book. Here, the comparison shows us the components of each bottle and its concentration, because measurement helps us to determine the type and the concentration of the element forming the substances or of the substances. Here we have two bottles, bottle A and bottle B, and the components, the elements forming each water inside each bottle. So here in bottle A we have sodium ion. The concentration of sodium is 25.5. The potassium is 2.8. The magnesium is 8.7. Calcium is 12. Chlorine is 14.2. Bicarbonate is 103.7. Sulfate is 41.7. This is in bottle A. But what about bottle B? Bottle B includes 120 milligrams of sodium, 8 milligrams of potassium, 40 milligrams of magnesium, 70 milligrams of calcium, 220 milligrams of chlorine, and 300 35 of bicarbonate, milligrams of bicarbonate. And also we have 20 milligrams of sulfate in each liter in these bottles. How did I determine the units used in determining the concentration? From the for information that this person who gave me this example told me before. He told me that the following table shows the components. The following tables shows components of two bottles of mineral water expressed in milligram per liter. When I say something like milligram, this is a measuring unit. We'll discuss it later. This part we're calling this mark for division. We're calling it per, means for each. For each. Okay, means for each. So here we have milligrams per or for each liter. For example, the concentration of sodium in bottle A is 25.5 milligrams for each liter of water in bottle A. This is how to express this sign. Number one, the first question. Suppose a consumer, person who's used this water, drinking this water, follows a nutritional system. He has a diet, so he follows a diet. Follows a nutritional system with low salts. Low salts. Which bottle will he choose? Which bottle do you recommend for this consumer? Actually, he's following a nutritional system with low concentration of salts. So it's obvious that this person will choose the bottle which has low concentration, the lowest concentration of salts. Here let's compare between the two bottles. Bottle A has 25.5 milligrams of sodium per liter, while in bottle B it has 120 milligrams per liter. So obviously the first bottle has the lowest concentration of the sodium ions, which form a salt. Although about the concentration of potassium ions, bottle A has 2.8 milligrams per liter, while in bottle B there is 8 milligrams of potassium for each liter in bottle B. And the same here. So bottle A, as you can see, has the lowest concentration of salts. So this consumer, will choose bottle A for his nutritional system, which is following a low concentration of salts. Question number 2. As a person has consumed 1.5 liters per day, 1.5 means 1.5 liters of water for a day from bottle B. He consumed 1.5 liters of water B in one day. Great. He's asking you to calculate the mass of calcium. Calculate UTS. He asks you to calculate the mass of calcium that he gained from this amount of water during the day he consumed this amount of water in. Let's say this guy is consuming from bottle B. Okay, in bottle B, each 1 liter in bottle B contains how many milligrams of calcium? Each 1 liter of water in bottle B contains 70 milligrams of calcium ions. That's great. How many liters did he consume in that day? He consumed 1.5 liters of water in bottle B in the day. So what is the mass, or what is the concentration of the salt that he consumed in this 1.5 liters per day? In this comparison, we are doing our scissor and getting the results. As you know, the known numbers will be multiplied together that you know from your preparatory stage. So 70 is multiplied in 1.5 divided by the number which is against the unknown. So the unknown is here, so we'll divide it on the number against it. So it's 1 liter. The results will be 70 multiplied in 1.5 equals 105 milligrams of calcium in the 1.5 liter of water in bottle B. This is how to measure the mass in this bottle.